All right, so define and sketch assignment, hydrogeology unit. We're going to have 3 define and sketches. And just make sure that you have all of these written into your book. We spent some time Monday writing them down. I just want to make sure that you guys have this. The first define and sketch, number 1, water cycle, precipitation, evaporation, condensation, aquifer, infiltration, absorption, runoff, hydrosphere, geosphere, and atmosphere. We're going to talk about half of those words in class today and define them, give you examples, and give you illustrations so you know what is what. And if you've had any questions in doing the define and sketch that I assigned on Monday, this might help you answer some of those I didn't know how to draw, I didn't know how to define questions. Okay? The rest of them, like aquifer, infiltration, absorption, and runoff, those 4 we're not really going to get into today, but those are in your book. If you, not sure what they are, you can look in the book or obviously dictionary or dictionary.com. The other 2, we'll start talking more about those in the next several days, and I'll assign those as we continue forward. So, the other thing I wanted to make sure that you got on Monday, finished writing, was the hydrogeology unit expectations. They're written on the front board as well over there in brown, those 3 unit expectations. I read them to you and we discussed them in class on Monday. So just make sure you still have those in your notes. And make sure that those are the things you're focusing on when you're trying to study for this task, that you're making sure that you can actually explain and understand everything in those expectations. Any questions? Okay. All right. So the first thing that I want to get into today is we're going to read some background knowledge about this unit. So I need a volunteer who would like to read. All right, Chris, go ahead and read that first paragraph for us.
Background knowledge. Fresh water moves over time between the atmosphere, hydrosphere, surface water, wetlands, rivers and glaciers, and geosphere, groundwater. Water resources are both critical to and greatly impacted by humans. Changes in water systems will impact quality, quantity, and movement of water. Natural surface water processes shape the landscapes everywhere and are affected by human land use decisions.
All right, so there's some terms up here which are your vocabulary terms also. We have atmosphere, hydrosphere, and geosphere, all of which you had to define and draw a picture of. The atmosphere. What is the atmosphere? If you had to explain it to somebody, how would you explain it? Go ahead.
Space.
Okay, something in space. A little more detail, because that's a little too vague, right? A little more detail.
Gases that protect the Earth, like the gases that are on the outer layer of the Earth protecting it.
Okay, good. What else did you want to say, Gabby? You have something else?
It's kind of like that. Like the blanket of gases surrounding it.
The blanket of gases surrounding Earth. Anybody have something different or want to add? Okay, so we have these layers of gases that are surrounding our planet that are protecting us from certain things from outer space, right? Solar radiation being one. And it also acts like a blanket, as we talked in the severe weather unit. We talked about, what? Say that out loud. Greenhouse effect, right? So the atmosphere acts like the what of a greenhouse? The glass. Awesome. Okay, so that's our atmosphere. So do we have water in our atmosphere?
Yes.
In the state of what?
Gas.
Gas, called what?
Water.
Water vapor, okay? And then we have something called the hydrosphere, and that is surface water. Any water that's laying on the surface, that's what we call our hydrosphere. Hydro meaning water, okay? So we have this surface of water, these layers of water on the surface. Things like streams, wetlands, puddles, ponds, lakes, oceans, tributaries, rivers. All of those things would give us what we call our hydrosphere, water on the surface. Then we have something called the geosphere. And that is the study of, and it is, all the layers of the earth. So beneath the ground to the core of the earth. Everything in between. And there's water underground in something called aquifers and aqueludes, and we have water tables and wells. All of that water is underground. Could be a few inches, could be several feet, could be hundreds of feet deep. So groundwater is in our geosphere. It's underground. Okay? Everybody clear on those? All right, so the second paragraph science terms are so essential for understanding during a lesson and need to be the background knowledge. Would you not agree with that? If you don't understand the terms that you're going to be reading, you're not going to learn what you need to learn. So that's why it's so important that we have a unit word wall every unit. There are certain words you need some introduction to and some understanding to be able to understand the bigger picture or the big concepts of the unit. Okay, so for this unit, these are some of those words: hydrosphere, geosphere, atmosphere, water cycle, hydrogeology. Remember we talked about this on Monday. Hydro meaning what? Geology meaning what? Study of Earth. Okay, so water on Earth, or Earth's water. Precipitation, runoff, absorption, infiltration, evaporation, condensation. Those words we'll all look at when we see pictures of and we talk about the what? Say it out loud.
Water cycle.
Yeah, the water cycle. Streams, or springs, streams, tributaries, those are all very small rivers in a sense. They're the smaller versions of rivers. The springs kind of feed into the streams feed into the tributaries feed into rivers. So that's kind of like going from size smaller to larger. Then we have rivers that feed into lakes and ponds, wetlands, geysers. Anybody know what a geyser is? Yes.
It's like a whole bunch of hot water coming out of like a mini volcano.
Okay, kind of. What'd you say?
Out the ground.
Water that's coming, shooting up out of the ground. What's one of the more famous ones here in the United States? What's the one in Yellowstone called? Old Faithful, okay. Permeable and impermeable. What does that mean? Anybody know? If something is permeable, what does that mean?
That water can flow into it easily.
That water can flow into it easily, okay? That there's lots of open spaces. And impermeable would be that it's not able to flow through those spaces easily. There's not a whole lot of space, right? We have a zone of aeration, saturated zone, unsaturated zone, which you read a little bit about in that groundwater article from Expert Space. And we'll talk more about that. We'll look at some pictures. Then we have something called recharge and inputs. We have discharge and outputs. Then we have the stream-based flow. And then we have, obviously, we all know, water pollution. And we'll talk about different types of water pollution and the effects it has on our water quality and quantity. Okay? All right. Core concepts. I want you to write this down. This is important for us to understand. Okay? This is really the focus of why we have this unit. Why do we have to learn about hydrogeology? Well, we all drink water. It's essential for our life. So without water, we cannot survive. So it's really important. The amount of fresh, drinkable water on Earth is less than 3% of the total water on Earth. So only 3% of the water on Earth can we actually drink. And actually only about 1% of that do we actually have access to right now. Why? Anybody know? What happened to the other 2%? Where is that at?
Underground?
Not underground. No, not gone. It's on Earth. No.
Is it polluted?
No.
Sewers in the clouds?
No, not clouds.
Yeah.
No, it's here on Earth. Sewers. We can even touch it, but we can't drink it.
Rain? Acid rain?
Huh?
It's a gas.
No. Okay, you talked about liquids, you talked about gas, what else did you forget?
Ice?
Ice.
Oh.
I said glaciers, right? So a lot of our fresh water is caught up in these glaciers that we can't, we don't want to melt our glaciers on purpose because they serve a very important part of our whole system here on Earth, but So only about 1% of the water on Earth can we actually use for drinking water because it's liquid. All right? That other 2% is really kind of caught up in all those big glaciers and icebergs and things like that. There's currently a global water crisis. Okay? We talked about Monday that in the future there could be water wars, right? Because there'll be a shortage of water and countries might go to war over having water. Okay? We go to war over oil, right? Because there's not a lot of oil here on Earth because we've been using it up. The same thing might happen about water. Elements of the hydrosphere, remember water that's on our surface, lakes, oceans, streams, rivers, things like that, are interconnected. Interconnected meaning they flow into each other. So streams flow into rivers, rivers flow into lakes. Many important groundwater reservoirs around the globe are not currently sustainable because recharge does not equal or exceed the output. What does that mean? That means what?
Is it like it's being used up faster than it's being replaced?
Yeah, it's being used up faster than it's being replaced. We're drinking it, using it for laundry, using it to build things. All right. We're using it for laundry, to build things. We're using it in factories to cool off machinery. We use it to drink. We use it to do dishes. We use it to flush our toilets. We use it to run our dishwashers. What else do we use it for? Showers. Showers.
Toilets.
Water our lawns. Toilets. Cleaning things. Growing things. Watering our lawns. Watering our plants. Pools. Yeah. We use a lot of water. Before humans, all that water wasn't being used. So Earth is like, whoa, slow down, 7 billion people. You're using it up too fast, right? It's having a hard time recycling it in its water cycle to replenish our fresh water. So as humans, we need to make a more conscious effort to conserve water. And as future scientists, we are looking at your generation to help us find better ways to use water and to replenish it quicker, to clean it faster and clean it better so that we can have more water and use it continuously.
Do you put like a tank like in your toilet tank?
Yeah, to conserve water, people do put, and you can put like half-gallon milk containers or juice sometimes, but those plastic jugs that are half gallons, you can fill it up with sand or you can fill it up with water, put it in your tank so that your tank isn't filling up full, it's only filling up a third of the way or 2/3 of the way, conserving water. Your tank doesn't have to be completely full to actually flush the toilet each time.
Unless.
So you're conserving water, you're paying for less. All right? Okay. The last thing on here, it says population demographics, which means how many people are in certain areas, how populated are we, and the land use practices have profound or significant or devastating impact on our water quantity meaning how much, and our water quality. So we have a huge, huge, huge responsibility as humans to conserve our water and to replenish our water as quickly and as best as we can so that we don't run out. Okay, there's an aquifer that covers about 6 states in the Midwest. And that aquifer, the Ogallala Aquifer as it is called, in the last 100 years has significantly been used up. It's a natural reservoir deep in the ground that humans are pumping water out to use because not everywhere, like here in Michigan, we have the Great Lakes. And we tap into that water source. Other people have to tap into these deep underground aquifers, these underground reservoirs, to get fresh water. And all the states on the West Coast, a lot of them, use this huge reservoir as their source of fresh water. It is being used up quite quickly. And it took 20 million years to fill it. And it's not full anymore, and it's only been about 100 years since we have tapped into it and started using it. So in 100 years from now, it's going to be very low. It's not being replenished as fast as people are using it. Carol?
How much to
toilet when you're pouring on it, right? This is really anyway. They have toilets that if you flush it up, you use less water. If you flush it down, you use more water. I guess you can imagine.
Yeah. Chris.
Like already like overseas countries going through the same thing for the water.
Yes, other countries are going through the same thing. Across the world, there's a water crisis, not just here in the United States. And other countries are at severe crisis levels of not having fresh water at all for their people. For example, which one of these cups of water would you like to drink?
Neither.
The one in my right hand or the one in my left hand? The one in my right, the one that looks clear and clean, not this one that looks a little yellowish.
Would you?
Okay, this is not apple juice. This is water out of that faucet. Oh! Why? I'm just telling you. Some people have no choice. Some people, this is all they have to drink.
Would you drink it?
So it's going to get to a point that if we don't take care of our water and make sure that we are conserving. How many of you run the water the whole time while you're brushing your teeth? Come on now. Conserve water. How many of you run the shower water the whole time? I know ladies, we shave, right? We shave our legs, and that takes a few minutes. The shower, shut it off, shave, then rinse. How about your hair? While you're scrubbing in the shampoo and the conditioner, ladies, shut the water off for a few minutes. That's what it's you can save gallons and gallons and gallons of water just by doing that.
Do you do that?
Yeah. And my kids do it too. Listen, anytime you can conserve water. How many of you wash dishes?
I wash it.
Okay, wash dishes. Do you leave the water on the whole time? How many of you leave the water on for more than you really
Oh my
need?
god, I can like raise
Come on now.
I can raise my hand.
Right? We all can do little parts to conserve. Even if you save a gallon a day. Do you drink a gallon a day of water?
No.
I should. But point is, if you save that gallon every day, we have more water for the future. How many of you would like to have kids in the future? Right? How many of you think your kids would like to have kids in the future? Okay, okay, not everybody. Most people want to have kids in their future. They want to have a family. Don't you want your family to have water?
Yeah.
And clean water? Or do you want that yellow water?
That's a good one.
Right? All right. Big idea. Oops. Big idea. I want you to focus on this unit. Finding solutions to problems related to water resources requiring an understanding of the dynamics and the interconnectedness. Remember how we talked about the streams are connected to the rivers flow into the lakes, that thing? Of the hydrosphere and the impact created by us, humans. The animals aren't going to fix our problem for us. The plants aren't going to fix that problem for us. We need to fix the problem because we are the problem. We don't conserve enough. Yeah, I want you to write the big idea in your notes. We don't conserve enough, and we need to be more creative and find different ways and faster ways to clean our water, and to purify our water, and to recycle our water.
Didn't you like boil ocean water into the fresh water?
You probably could, yeah. That takes a lot of time. But what lives in the ocean that we also, food, live on? Lots of food. Lobster, shrimp, fish, snail, whatever else they eat out there from the ocean, right? There's lots of food that they eat. No, I only want you to talk the big idea. Okay? Question.
Don't they have like water filters? Like filters?
We do, yes.
What?
For what? You're talking about to do what?
Don't they clear us the
Like
water?
to make
They do, but we're using it so fast. That has to sit for weeks. It has to go through filtering systems that take weeks to do. We need to find ways that take less time.
I'm gonna invent a machine that does that.
Can't you live off water for like at least 2 years?
Live off of water?
Yeah,
Just water?
Yeah, like just water.
I don't know. I don't know exactly how long. I think you would need more than food, more than just water to survive for 2 whole years.
So you froze it on ice.
So you need some kind of other proteins and whatnot, just kind of.
Yeah, if you don't.
A couple of months maybe you could go with just water. I'm not really positive exactly how long. All right, questions on any stuff that we've discussed so far? Yeah.
So like I read like yesterday for the water essential whatever. It says sewage water is good for our crops.
Yeah, but it has to be filtrated at some point. You can't just pour pure sewage on it.
Oh,
Okay, it has to be filtrated at some point to a certain extent. Okay, you're not going to pour exactly what you have in your toilet onto your vegetables in the backyard. Right? Not a good idea. Okay, lots of E. coli involved in that, and that can be very deadly.
Yes, it can.
All right. Okay. I'm going to go on to the next thing. And this is all on my website, so if for some reason you're not catching everything, go on there. So now we're going to talk about the water cycle. And it's mostly review because most of you should have been taught something about the water cycle. What processes do you are familiar to you? Precipitation, evaporation, and condensation. There's one more that you need to know that might be new to you. What is it?
Accumulation.
No, but that is a good word to know. All right, accumulation is how much precipitation we might get, an amount, right, a buildup of. But the other word I want you to become really familiar with is called transpiration. And transpiration is like a type of evaporation. It's when water vapor is taken from or released from the pores of leaves, from plants, flowering plants, bushes, trees, grass. Water vapor comes from them. You know how we sweat and you get, people beat up and they got the sweat droplets? That's water perspiring from you, right? Well, the same thing kind of happens with plants. They perspire, but we call it transpiration. Instead of perspiration, we call it transpiration. And that's one more way water vapor gets into the atmosphere. Okay? All right. So let's start. On Earth, water moves around and changes form. What does that mean, changes form? What's a change from what to what to what? Solid, liquid to gases, right? Changes back and forth. That's called the water cycle. What are the parts of the water cycle? Adam,